project or the series, and as you can see, we have completed 44 problems, and today we'll probably do one problem, and the next problem is problem number 45. So let's take a look at the problem. Okay, and it's triangular, pentagonal, and hexagonal numbers. I think we had done a very similar problem in the last, let me check. I think the previous problem was something very similar. It's only this. So in this problem there are three different types of numbers. There's a triangle number, there's a pentagonal number, there's a hexagonal number, and it can be verified that this triangle number, which has some index, is equal to this pentagonal number, which has this index, and this hexagonal number, which has this index. So we have to find the next triangle number next, so it obviously has to be greater than 285. That is also a pentagonal number and a hexagonal number. So that's it's going to be a for loop, so it's not very complicated. What we're going to do is do something that's very similar to what we had done previously. Let me bring my iPad over here. Okay, before I do this, it's been so long since I last created a video, I've forgotten the usual things that I typically do. So first, let me create a new Jupyter notebook. So that would be that, and copy the problem. So I will name the Jupyter notebook problem 45, like that, and let's copy the problem. That's problem 45. That is problem 45, and that is a triangular, pentagonal, and hexagonal number. That's the name of the problem, and let's copy paste the entire thing over here. Okay, and these are subscripts. Markdown subscript. Markdown subscript. Oh my god, these are HTML. Never mind. So that's that, underscore, like that, and this is the subscript for this, and this is the subscript for this. There you go. So we have subscripts like that, and TN is also a subscript, but never mind. Can we quickly do this? So like that, like that, like that, and this is subscript, this is subscript, and this is subscript as well, like so. And these should be I think that would do it. Okay, so now how are we going to solve this problem? All right, so take this. So we have these triangular numbers. Let me bring the iPad over here. Okay, So we have these triangular numbers Tn equals n into n plus 1 by 2. We have Pn equals n times 3n minus 1, and we have Hn equals n times 2n minus 1. So those are just the three different types of numbers. We are just going to, given a series of n, we are going to get a series of triangular numbers, and we have to check whether that triangular number is a pentagonal number. So we will just invert these problems. So there is a by 2 over here. Is it n times 3n minus 1 by 2, and Hn equals n times 2n minus 1. So just like we had done previously, we are going to invert these numbers. So 2Pn equals 3n square minus n plus 0, right? So n square minus n minus 2Pn equals 0. So if it's a pentagonal number, it should follow this equation, which basically means that we can solve for n. N is minus b plus minus b squared minus 4ac, 4 times 12 to the 24, and there's a negative 24, and then there's a Pn by 2a by 6. So this, if this comes out to be an integer, then we know that this is a pentagonal number. So this has to, so given an n, if this comes out to be an integer, and we know that this is going to be greater than 1, so we don't have to worry about the negative sign, only positive signs. Okay, because pentagonal numbers start with n equals 1, apparently. Okay. The next one is a hexagonal number. We will do pretty much the same thing. We will look at 2n square minus n minus hn, that's a hexagonal number, and that equals 0, and n equals minus b, so that's one, plus minus b squared, that's 1, minus, and that minus becomes plus 4ac, it's 4ac by 2a, that's 4. So if this becomes an integer given hn, then and in this case tn is going to be equal to pn and hn, and under those circumstances we have to check whether this is going to be equal to an integer. So that's the one that we have to check. Oddly enough, wait, let me check. Let me see. What are the conditions in which 24, so for this to be an integer, square root of 1 plus 24 Pn has to be a square, a whole square. Let's not worry about it. Let the computer do the work. I don't think we need to think too much about such things. Excuse me. So let's solve this problem. I will keep these things over here. This should be a really simple problem. It should not be very complicated. Okay, so first we have to create a generator, or we don't have to create a generator. We'll just put a while loop, and we have to create a check for pentagonal number. Pentagonal number, is it? It's called pentagonal, yeah. Number that takes an n, and that's an integer, and returns a boolean which will be true if it is a pentagonal number, otherwise not. Okay, so let's do it, and we'll call it Pn, just like that, just like that, and return. So Pn into 24 square root 1 plus 24 into Pn plus 1 by 6 by 6 is to check, something like to check is that, and if to check is the same as the integer of to check, then return true, else return false. So let's check a few pentagonal numbers. Is pentagonal 1? We have a problem. NP. Okay, let's import we don't have to depend upon numpy then. All right, so for I in range 10, P equals 1 to 10. P equals pentagonal n into n 3 into n minus 1 by 2. Okay, and if it's pentagonal, print p. Okay, print p, and yes, else print p, and no. N is not defined. Where is N? There should be N. Okay, so it looks like pentagonal is correct. We will also do something similar for hexagonal. Is hexagonal, and this should be hn, and the equation that we are looking at is wait, this is, oh no, this is correct. 1 plus, so there's supposed to be an hn, eat like that, divided plus 1 divided by 4, in this case 4, like that. Okay, so this would be hexagonal, and let's check for hexagonal numbers. Hexagonal numbers are 2 times 2n minus 1, n times 2n minus 1, and there is no 2 at the end. There is no 2 at the end. Okay, let's check, and we have a problem because we are checking for the wrong number. Is hexagonal, so this seems to work. Okay, so now we want to create a series of triangular numbers or triangle numbers and check whether they are pentagonal or hexagonal. So for I in range, I don't know, 5,000. Okay, then we will create. Okay, what's required over here? Find the next triangle number. So I need the Tn. Tn equals, why do I always make it n1 onwards? You don't need the other ones. So n equals n into n plus 1, n plus 1 by 2, and we know that this n and n this is always going to be even, so there should be an integer. Okay, so given that, if not, which one is easier? For the computer, both are similar. Okay, if not is pentagonal of Tn, then continue. Okay, if not is hexagonal, is hexagonal Tn, and otherwise print Tn. So we are hoping that it's going to print 285. All right, it's going to print 285 and then break. And if it comes to this point, it will print this and break. We don't want to go on. 1 is wow, yeah, that is true. Damn. Wait, is that not a solution? Find the next triangle number. So they are clever with the wording. Okay, let's see. 40755. Find the next triangle number. So this is the triangle number that we're looking for. Okay. 40755. That's the one after this is what they're looking for. 285. So I need to start with 286. 286. And then go up to maybe 10,000. I don't know. 10,000. And are we going to nothing? Wow. So over here, this is probably a very big number. So let's just run a for loop, and if it doesn't return anything, then we'll see. So n equals 284 while true. I will add n plus equals 1 plus equals 1. Okay, and I will check whether I am able to get this 285 number, and it breaks properly. So it does. So I need to increase this to 286, and okay, we have an answer. I don't know, shall we time it? (41 milliseconds). All right. (40.1 milliseconds). Okay, so that's the answer. I think that's the answer. It's a very simple problem. It's not very complicated. So okay, so we have solved the next problem. I will stop over here. We have been streaming for about 22 minutes. So we'll stop over here, and let me again request you to like and subscribe if you have made it so far, and if you like such videos, and I will see you next time. Bye bye.